this is the solutions. These are the solutions to quiz 1, the practice quiz 1. An object starts at x equals to plus 5 and moves left with the, along the x-axis at a constant speed. Which graph could represent this motion? Okay, so it starts from some positive value, and it has to, so Vx must be negative, so the slope must be negative, and x must also pass through 0. Okay, so this is the best graph here. This is the x-axis, passes through 0. Okay, the next problem is kind of a difficult problem just for simply trying to figure out positions of points, not for physics reasons. A car is moving along the x-axis and its velocity vx varies with time as shown in the figure. What is this displacement? Delta x of the car from t equals 1 to 8 seconds. So the key point is that the displacement is the time interval under the velocity versus time curve. Okay, so we go from 1 to 8 seconds here. We need to get the area of this triangle, the negative area of this triangle, the area of this triangle. So we need the signed area. So triangle 1 is 1/2 base times height, 1/2 base times height here. Okay, 1/2 base times height here. But this one will end up being 0, or negative here. Okay, so triangle 1 and 3 are above 0, triangle 2 is below 0. And so then in the end, delta x will be this 1/2 b1 h1 plus 1/2 negative 1/2 b2 plus b2 prime h2 plus 1/2 b3 h3, where everything's defined here. Now the rest is just trying to figure out what b1, b2, b2 prime, b3, h3, h2, h1 are, and that's just all geometry. I don't consider this an essential part of the physics practice stuff, but this is all from similar triangles. How do you get all these things? Let me just show you. For example, if you want to get what h1 is, you have a similar triangle. So we're looking at this triangle here. Okay, so we have this little piece, that little piece is this guy here. The whole side is 35. Okay, and so now this ends up being a distance of 1. This ends up being a distance of it's actually this whole triangle here. This distance ends up being 5. It's actually this whole triangle here that I'm just talking about. And so we can say that 25 minus h1, because h1 is this here, okay. H1 is this here, right? And this is 25, so this little piece is 25 minus h1. Sorry, it's a little inconvenient switching back and forth like this. So this is 25 minus h1. Okay, and this will be h, and there's an extra 10 here, so it's h1 plus 10. So the ratio of this side to this side is equal to the ratio of this side to this side. So that's enough to solve for h1. Now to get b1, we're going to take this triangle here. Okay, that'll be so this triangle right here has a side b1 plus 1, and then the full triangle here will again be this guy here. So that will be enough to solve for b1. So we get b1 plus 1 over 25. And similar triangles 5 over 35. That can be used to solve for b1. And then the rest is actually more simple. You can calculate b2 and b2 prime as well. So I'm using the fact that b2 plus b1 is equal to 4. Okay, b2 plus b1 is equal to 4. That gives you b2. And then, so then b2 is 1.43 seconds. Now h3, you can just read that off. That's you can see that that's 5 meters per second. b3, you can just read that off as well. That's going to be 1 second. Okay, and so that's enough to solve for everything. No, actually there's one more. So b2 prime plus b3 is equal to 3. v2 prime plus v3 is equal to 3. That distance here is 3. And so that gives you v2 prime is equal to 2, and that's enough to solve for delta x. Okay, and you end up with 8.48 meters. All right, all this stuff here is just a lot of similar triangle stuff, not really essential for the physics class. Okay, next problem. The graph shows a plot of position versus time for an object. Which of the following statements is true during the time interval shown? Okay, so notice that here's the slopes. I'm drawing the slopes. Notice that it starts with the big positive slope, and it keeps getting smaller and smaller, and finally goes negative. Okay, so the slope keeps decreasing, so Vx is decreasing with time. Slope keeps decreasing with time. Vx is decreasing with time. Okay, so Ax must be less than 0, so the acceleration is always negative. Next problem. The following is a graph. The graph of Vy as a function of time. Okay, we have this constant slope, flat slope, and a constant negative slope, constant positive slope. Okay, here the acceleration is greater than 0. Here it's constant y. Here the acceleration is less than 0. Here the acceleration is greater than 0. So they want to know which one is the possible plot of y versus time. So to get, in the beginning, we have to have a positive acceleration, so it has to curve up like this. That's actually enough to figure out that D is the only candidate. Then in this region here, it's constant y, constant dy. So it's a constant slope here. And then we have negative acceleration. So it's going to curve down like this. It's going to bend over like that. And then it's going to have positive acceleration, so it's going to curve up like this. So D is the choice. An airplane starting from rest accelerates for 227.0 seconds before taking off. Its speed at takeoff is 72.0 meters per second. Assuming the acceleration remains constant, how far does the plane move before becoming airborne? Okay, so the initial is 0, the final is 72 meters per second. Delta t is 27 seconds. So we can do a one-step solution. Is 1/2 the average of v0 and v times delta t. So we have 1/2 72 times the average of v0. So the time. The average of v0 and v is 1/2 72. The time is 27, so multiply these together gives 972. Now, by the way, if you wanted not to use that formula, but maybe something more familiar, you could do a two-step solution using only equations on the formula sheet. You can get the acceleration as delta v over delta t at 72 over 27. That comes up to 2.67 meters per second squared. Then you can use the fact that delta x is 1/2 a delta t squared plus v0 delta t, where v0 is 0. And we get 1/2 2.67 times 27 squared, which is 973. You may find this more straightforward, even though it takes some extra step. Okay, a ball is thrown straight up in the air at a speed of 70.9 meters per second. If you ignore air resistance, what is the maximum height the ball will reach? Okay, this is the positive y direction. So v initial is 17.9, v final is 0. Okay, at the maximum height, the y component is 0. Ay is negative 9.8 meters per second squared. So we want to know delta y. So we can use v squared, v final squared minus v initial squared is equal to 2ay times delta y. Solving for delta y, we get v squared minus v0 squared divided by 2ay, plugging in so that we have v is 0, v initial is 17.9, and then divided by 2, and then ay is negative 9.8. We get 16.3 for the distance. That's y. Now, next one, 2 identical stones are dropped from rest and feel no air resistance as they fall. Stone A is dropped from height h. Stone B is dropped from height 2h. If stone A takes time t to reach the ground, stone B will take what time? Okay, so it starts off for both stones. that the that the initial velocity is 0 in the y direction, ay is negative 9.8. So let's do the first term. Delta y is negative h. That's how far it falls in this time. Okay, so delta y is equal to 1 half ay delta t1 squared plus v0 delta t1. So we can solve for delta t1. We have negative h is equal to 1 half minus 9.80 times delta t1 squared. So delta t1 is equal to the square root of h over 4.9 over g over 2. Now for the second stone, we're going to take delta y to be negative 2h. And so we're going to do all the same things. Everything will follow through except we're going to have a 2 here. And we'll get square root of 2h over 4.90. So the question is, when I stare at these two, what is the comparison? So there's an extra square root of 2 for delta t2. So it's a factor of delta t2 is a factor of square root 2 bigger. So delta t1 times square root 2. Next problem. A runner has a mass of 64.3 kilograms, starts from rest and accelerates with constant acceleration 1.25 meters per second squared until she reaches a velocity of 7.1 meters per second. She then continues running with this constant velocity. How long does the runner take to run 194 meters? Okay, so there's two parts here. So first we have constant acceleration. So A is delta V over delta T1, and so we can use this what we're going to do is we're going to solve for delta T1. So A times delta T1 is equal to delta V. Delta T1 is equal to delta V over A. I did that in a whole bunch of steps. You could have done that much more quickly. That's 7.1 divided by 1.25. That's 5.68 seconds. Now we're going to calculate delta x1. How far we go in the first part with constant acceleration. That's 1 half A delta T1 squared plus V0 delta T1. The initial is equal to 0. So we get 1 half 1.25 for the acceleration times 5.68. That's given here. That's what we calculated here squared. That comes out to 20.2. Now in the second part we have constant velocity. So then in order to figure out how long this is going to take, so the total distance traveled is 194 meters. Okay, so we can calculate now so we take 194 minus the delta x1 that we calculated in the first part. That's 173.8 meters. That's how far we have to travel for the second part at constant velocity. So we can calculate delta t2. So that's delta x2 divided by the speed. 173.8 divided by 7.10. That comes to 24.5 seconds. So this mass is completely irrelevant, by the way. Find the vector's length. If the x component is 2.25, the y component is negative 5.87, then 3.3 is 33.5 and negative 58.7. Okay, so the magnitude is the sum of the squares, take them and then square root. So 33.5 squared plus negative 58.7 squared. Take the square root, gives us 67.6 meters. And they want the angle counterclockwise relative to the x-axis. So you can do this in several different ways. Let's do it this way. We have 33.5 here. We have 58.7 here. This angle theta will be sine of theta is 58.7 divided by, so that's the opposite side, and this is the hypotenuse, 67.6. That's given by the hypotenuse here. And so theta comes out to 60.3. That's this angle. If you want to know what this angle is, measure counterclockwise from the x-axis. That's 360 minus theta, so that's 299.7. You could have done this in several different ways. Okay, and here's one alternative. So if I want to just measure alpha directly, so then alpha is the arctangent, inverse tangent of AY, which is negative 58.7, divided by AX, which is 33.5. And so we get that the arctangent is negative 60.3. This is the angle we want. Okay, so you can think of this as negative 60 going the other direction, right? So we're going to add 360 to this to give 299.7